So, short week this week.
Oh,
Yeah.
we love
Okay.
that.
So, no school on Friday. We're going to do solving systems of equations by matrices today. Okay. I am not going to force you to solve a system of equations using matrices at any point in time this week, other than on the homework tonight. Okay? It's just another option, another tool for you to have in your toolbox. On Thursday's test, there is no specific solve using matrices questions, is what I'm saying. Okay? It's just there for you. Tomorrow, formative in the Resource Center. Wednesday, we'll do a review type activity in class. Thursday test. Okay? So a quick hitting week, plus, hey, my thing needs to be updated, so, let's go. All right, so we need these two concepts in order to go forward today. So a great warm-up. One, finding an inverse, which would have been Thursday's notes, I believe, was Thursday's notes, and multiplying would have been Wednesday's notes. Okay, so remembering back Wednesday, Thursday. Go for it. Give you a couple minutes. Alright, so before we find the inverse, the first thing we've got to find is whoa, went too far. We got to find the value of the determinant. So the determinant for this one is going to be 10 times negative 3. Oops, not plus. Tap the brakes. That's a minus. Minus 5 times negative 8. So that's negative 30 minus negative 40, which is positive 10. So the inverse, no name, so we'll just call it INV, is going to equal 1 over 10 times the matrix. Switch the main diagonal, so that's negative 3 goes up there, positive 10 goes down there, negate the other two, so that becomes negative 5 and positive 8. Yes? Okay. All right. 2 by 2 times a 2 by 2 results in a 2 by 2. So then we got 8 times 5 plus negative 2 times negative 4. 8 times 3 plus negative 2 times negative 1. Negative 6 times 5 plus 0 times negative 4. Negative 6 times 3 plus 0 times negative 1 gets me 40 plus 8 is 48. 24 plus 2 is 26. Negative 30 plus 0 is negative 30. Negative 18 plus 0 is negative 18. Yes, no, maybe. Okay. Good? All right. Hey, let's get into it. Let's do it. So, the very first thing that we have to do is we have to take our system of equations and we have to convert it into a matrix equation. Now, a matrix equation is an equation, shocking, that has matrices. Okay? So, the first matrix that you are going to do is you are going to have your coefficient matrix. So you're going to take all of your coefficients and you're going to put them in matrix form. Okay? So here's my coefficients. I'm going to put those in matrix form. 5, -2, 2, -4. Next off, you're going to have a variable matrix. In this case, it's X and Y. Little side note, if I were to multiply those two matrices together, green and black, I would get 5x minus 2y and 2x minus 4y, okay, which is the left side of my system of equations. Then you're going to have your constants, or your numbers, if you will. So now, if I were to multiply on the left side and solve, I'd have 5x minus 2y equals -10, and 2x minus 4y equals 12. Okay? So you got that going for you, which is nice. Okay? So that's the very first thing. We're going to take our system of equations, and this would work on any size system of equations as long as everything is lined up. Okay? And you would fill in, like if it was a 3 equation, 3 unknown, and you didn't have like a y term in one of yours, you'd fill that in with 0, because really it's plus 0y. Okay? Okay? Next thing that you're going to do now, after you've got this equation, is you are going to work the inverse of the coefficient matrix. Well, the coefficient matrix is that first dark green matrix. 5, -2, 2, -4. Now this work, I would probably do a little bit off to the side from your normal work. Okay? If you like everything to flow, this is a little sidebar action. Okay? So you're going to do this a little bit off to the side. So the first thing you got to do is you got to find your determinant. Actually, tap the brakes. Go in this color this time for determinant. Actually, no, we could have gone there. No, we'll stay in blue. So we'd have 5 times -4. Oops, I almost put plus. Minus 2 times -2. So that's going to be -20 minus -4, which is -16. Agree with me? Everything so far. Okay? Which means then that my inverse of my coefficient matrix is 1 over -16 times the matrix. Now I'm going to switch the 5 and the -4, and I'm going to negate the 2's. Right? Okay. All right. So now back in the flow, we're done with our sidebar action. So now that we're back in the flow, now what we're going to do is we're going to take our matrix equation. And I'm going to rewrite my matrix equation. And so that matrix equation again was, sure it was, there it was, 5 and -2 and 2 and -4. and then we had x and y, and then we had an equal sign, and then now I'm going to leave a little bit of a space because I know what's coming. And so we got that. Yeah? Love it. Excited. Yeah? Now it says multiply the inverse matrix by the number matrix. Well, that means if I'm going to multiply here, so I would put it on, because I want to get rid of this green one. So I'm going to go 1 over negative 16, because that's my inverse. And then we've got negative 4 and positive 2 and negative 2 and positive 5. I'm going to multiply there because remember, order matters when we're multiplying matrices, right? Right? Order matters. We did a couple of problems last week where A times B wasn't B times A. Okay? So since order matters, since I'm multiplying on the left side there, I'm going to multiply on the left side over here. Now, we'll see who was taking some good notes back on Thursday. When I take a matrix and I multiply it by its inverse, what do I get? Any matrix multiplied by its inverse. What do we get? You get what? You get the identity. Love it. Okay? So if I take any matrix and I multiply it by its inverse, remember blue and green are inverses, right? So what should those be? Those should be the identity. Now, when I take the identity and multiply it by the black matrix xy, what do I get? When I take a matrix and multiply it by the identity, what do I get? Also in your notes from Thursday. When I take a matrix and I multiply it by the identity. What? The matrix doesn't change, right? So since the red dashed box is matrix times its inverse, right? That becomes the identity. What's the identity times the black matrix then? Just the black matrix again, right? So this whole side boils down to that. Because we multiplied by the inverse. Okay? Now, on the other side, can I do that multiplication? Can I do that multiplication was the question. Do the dimensions line up? 2 by 2, 2 by 1? Okay, so we can do it. Okay, that's key. Because if we couldn't do it, I don't care if I can distribute in that or not. Okay, kicker is, can we do it? Yes, we can. Okay? I'm going to wait on the distribution until the end because I don't want to have to deal with negative 5/16. Okay? So I'm going to just tag that along. 1 over negative 16. Then, can't use purple. I'll use orange. Ends up being a 2 by 1 matrix. Yes? Yeah. So up here we would have negative 4 times negative 10 plus 2 times 12. Down here we'd have negative 2 times negative 10 plus 5 times 12. So now we've got 40 plus 24 is 64. 20 plus 60 is 80. Now I can distribute that in, and I get my matrix XY is equal to 64 divided by negative 16. 80 divided by negative 16. Negative 5. So now I get that. So what does that tell me? The point that these two lines intersect would be at the point negative 4 comma negative 5. Okay? So I can switch it back into point form. So my solution here would be, and at the same time, I can go back and I can check my work. So my original equation was 5x minus 2y equals negative 10. If I plug in negative 4 for x, that gets me negative 20. If I plug in negative 5 for y, that gets me negative 10. Negative 20 minus negative 10 is negative 10. My other equation was that. If I plug in negative 4 for x, I get negative 8. If I plug in negative 5 for y, I get negative 20. Negative 8 minus negative 20 is positive 12. Works out. So that is my answer. Now, I will be honest with you that solving using matrices is not very much faster in 2x2 systems of equations. Okay? Systems of equations that have 3 equations, 3 variables, 4 equations, 4 variables, yes, matrices is by far the fastest. Okay? 2x2s, probably not your most speedy type way to do it. Okay? Alright? What I'd like you to do now is I'd like you to utilize those skills to try and solve this system of equation using matrices. Sheet. So this would be 3, negative 4, 2, negative 3. X and Y. 5 and 3. then I'd go over here and I would say, all right, so my determinant is 3 times negative 3 minus 2 times negative 4. Well, that's going to be negative 9 minus negative 8. So that's going to be negative 1. So my inverse is going to be 1 over negative 1 times negative 3, 4, negative 2, 3. Right? So that tells me then that my right side, or my left side, is going to become that. My right side is going to become that. Negative 3 times 5 is negative 15. 4 times 3 is 12. Negative 2 times 5 is negative 10. 3 times 3 is 9. Oh, what's that? Negative 3. Negative 1. So I get, all the way down here, that x and y are 3 and 1. Let's check it. So the first equation was 3x minus 4y equals 5. If I plug in 3 for x, this is 9. If I plug in 1 for y, that's 4. 9 minus 4 is 5. 2x minus 3y equals 3. If I plug in 3, then that's 6. If I plug in 1, then that's 3. And 6 minus 3 is 3. That works out. So my answer over here would be 3, 1. Okay. Questions, comments, concerns? Need me to scroll back up? Good. Okay. I'm giving you 2 homeworks today. The first homework that I'm giving you is this one, and that one is due on Wednesday. Yeah. The second one that I'm going to give you is this one, and that one will be due on Thursday, because it's your review homework and you got some spare time tomorrow with no class. So.